In today's module, we're going to be looking at the Google Cloud Secure Web Proxy, or SWP for short, right? And this course is more or less sits at the level 200 level because it is introducing some advanced complex topics, right? And it is part of the Google Cloud Certified Professional Cloud Security Engineer Certification Program. Now, this specific product I'm rather actually quite excited about, right? And if you look at it, where secure, where proxy kind of fits in, it fits into that whole concept of outbound protection, right? And if you look in terms of like the market, the industry, we hear about this term about ZTNA, Zero Trust Network Access, and Gartner coined the term SASE. I do have a separate video on that. And if we dive a little bit deeper and look at the secure service edge that Gartner has come, this is kind of, you could think of, Google's spin on that, right? So if you think in terms of vendors like Netscope, iBoss, Zscaler, and some of those kind of vendors out there, that is strategically where this kind of, product kind of sits. But inherently, because it is made by Google Cloud, it actually sits inside the Google infrastructure, and there in itself has many advantages, right? So like I said before, I am rather excited about this kind of product because it does change the security landscape within the actual cloud mechanism here, right? So as part of this course, we're going to be talking about a lot of key concepts here, right? We're going to be looking at the benefits, the use cases, the strategy. What will be like a strategy of using a specific product, right? We'll briefly cover some of the features. We'll look at rule evaluation, and think of in terms of like if you look at secure web proxy, by definition, it is a proxy, right? And by that I mean that you are actually terminating a connection on the proxy and establishing a new connection, right? And we'll look at some of that advantages in the coming slides, right? We're also going to look about tags. We're going to look at policies. We're going to look about authenticating. How would even in a use case authenticate to the secure web proxy, right? No conversation would be without TLS, right? So no security conversation. So TLS is very important, and with TLS comes certificates. And when we are accessing it in terms of the kind of traffic that's going to go through that secure web proxy, it would be actually API, right? And by definition, if it is a proxy, if we are doing security, naturally we will do some traffic inspection, right? So these are some of the topics and domains we're going to be covering. So without wasting any time, let's dive deep into the actual product, right? So by definition, what is secure web proxy? So it secures your egress web traffic. And why do we want that? Is because we want to protect our internal infrastructure. We want to hide it behind an external wall, essentially, right? And that's what that secure web proxy is doing for us, right? It also provides us granular policies, right? So we want to be able to control the traffic that is going from an internal environment within Google Cloud to the outside world. We want to have that granular control through the policies. It's based on identities and web applications, right? Now, because it is a proxy, because it is a means of getting out to the internet, you have to explicitly configure something to use the secure web proxy as a gateway. So in terms of things, in terms of a router, right? So a router, if you're doing some routing, you probably what you'll do is you put a default route to the actual gateway, and that's how you would get out to the internet. So think in terms of that kind of concept here. Okay, now what would be our sources, right? So how would we be using the actual secure web proxy, right? So what are some of the mechanisms? So think in terms of a virtual machine. A virtual machine can be configured to explicitly use the web proxy, right? We can configure containers, right? We can configure serverless environments. And in Pacific, if we are to do a serverless environments, we would use a serverless connector by means of actually accessing that, right? And obviously, we don't want to think in just in terms of our posture our environment within Google Cloud, we also want to think in terms of on-prem, right, outside of Google Cloud, right? So let's say hypothetically we have a data center, we have an on-prem presence, right, and we want to use the secure web proxy. So simply what we would do is we would connect to the cloud environment using Cloud VPN or Cloud Interconnect, something secure, and then from there we would tunnel the traffic through the secure web proxy. So an endless amount of design options, an endless amount of architecture options. So that's what makes this product so great. So in terms of strategy, right, in terms of the solutions, right, what is supporting this initiative, right? So what we could do is, first of all, let's say we're an organization and we're on-prem inside a data center, and now we want to move to the Google Cloud environment, right? The secure web proxy can help us with this initiative. What it can allow us to do is it will allow us to keep our existing security policies and requirements for egress web traffic that will have on-prem. So let's say we have something similar on-prem. Now we move to Google Cloud. We have a product that we can take advantage of, which happens to also be a cloud native product. So you get all the advantage of elasticity, scalability, etc. Right? We don't have to use, a third-party solution. So let's say we're migrating Google Cloud, or we're already inside Google Cloud, right? We don't have to go out and buy a third-party solution. It is a Google Cloud native service, and with that, as I mentioned, the advantage of elasticity, scalability, high availability, etc. And another advantage that most people overlook is consistency with your GUI interface, right? With your graphical user interface. And what I mean by that is, imagine if you did have a third-party vendor, right? Let's just say you had another firewall, another proxy from another vendor. You would have to be dealing with that GUI interface. So you have to learn something new, and but this is all housed within the Google Cloud Console, right? So that's another advantage, right? Access to trusted external web services, so we can apply granular access policies to allow egress web traffic to where we trust, right? So let's say we trust something like Salesforce, right? So we can control our traffic to go directly to Salesforce, right? And we can identify these workloads, app identities, and then apply policies to web locations, right? What is the destinations or the targets we want to reach out to, right? And with the cloud, with the secure web proxy, because it is a native service, it is because it's from Google Cloud, it can natively integrate into so many different Google Cloud services, right? So we can do log to cloud logging, we can monitor internet usages, we can discover threats and response. So think of all the other Google Cloud service offerings, especially around security, to which this product can integrate into. Okay, so again, we already mentioned some of the benefits, but let's dive even more deeper into these benefits, right? So, operational time savings, right? So what I mean by that is, there's no, if you think in terms of like if we're going to put another vendor's proxy of a similar kind of functionality into GCP, we have to set up the VPN, the VMs, we have to update it, we have to put in solutions that allows us to scale. But with the secure web proxy, we're getting, there's no VM setups, right? There's no updates done automatically for you. We're getting the elastic scaling, so you don't have to manually configure extra VMs or high availabilities and all that kind of good stuff, right? There's already a default initial policy config out of the box, right? So we can do regional instances work out of the box. It simplified the setup of both, not only actually the setup itself, but the testing and the deployment. Okay. The secure web proxy also gives us an immense amount of flexible deployment options, right? So we have the instances, the actual instance of what we're generating here of a proxy. We have the policies that go on the instances, and we can deploy multiple instances that all use the same policies to different locations, right? So there's various different permutations around that. Different policies, different instances, same policies, different instances, different policies, right? And obviously, we can define URL lists, right? So think of this as whitelisting traffic, right? Okay, and obviously, the other benefit is that it's improved security. There is a default deny all automatic updates to software and infrastructure when it comes to the secure web proxy. Okay, in terms of the actual features, there is the actual explicit service, so clients are explicitly configured to use the proxy, and then it's set in stone. We can isolate the clients from the internet. So imagine this big wall that we're hiding our clients behind, and essentially it's doing that because we're building a new TCP connection on behalf of the client from the proxy to the outbound destination, the target. Right? Auto scaling envoy proxy. So basically, we can adjust the envoy proxy, basically the pool size, pool capacities per region. So it now enables us to auto scale as demand increases, but at a much lower cost, right? So again, many advantages around scaling and all that kind of good stuff. Okay, we do actually have modular egress access policies, and what I mean is that it's kind of like broken down in terms of what is the components, the mechanisms that we are controlling the traffic through, right? So we can do it through source identity based on secure tags, service accounts or IP addresses, destinations based on URLs and host names, requests based on the methods, the headers, the URLs, and URLs can be specified using list, wildcard, and pattern. So if you look at it, when we break down the modular aspects of defining a policy, is rich with so many different components and columns and fields that we can actually use at our disposal in order to control the strategy of how we want that traffic to leave our environment. Okay, it does provide end-to-end encryption, supports HTTPS connect for client initiated. So what I mean by that is basically you have your TLS connection or your secure connection from the client to the proxy, and then from the proxy to the end destinations, you will have that additional TLS connection as well. So you have end-to-end encryption all the way. Right? It is simplified with Cloud NAT integration. So if you think about it, the web proxy in itself is a proxy, right? But it doesn't directly deal with the actual network address translation, right? So that's all about public addresses and private addresses, etc. So because Cloud NAT is another Google Cloud native services, the integration happens very seamlessly, and now we can automatically add additional public IP addresses as loads increases. So now we're thinking in more terms of dynamics, like it's now we're combining web proxy protection with public IP address additional load as that load increases. Okay, as always in the Google Cloud environment, we have full audit logs available, and Secure Web Proxy is no exception. Cloud audit logs, all cloud operations, integrations with that Secure Web Proxy. Okay, so the Secure Web Proxy, think in terms of it is some, I don't want to use the word firewall, but it is some kind of like some shape, to some extent, a firewall in itself, right? So you'll have these rules, right? So you'll have a priority number associated. Those priority determines the rule order. And how do you make an action? How do you take an action on the actual traffic, right? And that is based on two approaches: a session matcher and an application matcher. And we're going to dive into these topics a little bit in the coming slides, right? So let's start with session matcher, right? So session matcher is basically focusing on session level attributes. And what I mean by session level attributes is in terms of the source machine. How are we identifying the session, right? And we can identify the session based coming from the source machine in a different number of ways: by the IP addresses, the service account, secure tag, host name. So those are some of our options there, right? We can also match in terms of the application matching, right? So let's move away from the actual machine itself, and let's now focus on the actual traffic aspects. And in this category, what I'm more focusing around is the HTTP request attributes, right? So the HTTP request attributes, right? And what are those? They're the URL, the path, the request headers. Again, rich level of elements that we can use to control the policies and the traffic. Okay, another feature that and it's just not specifically with Secure Web Proxy, right? This is something that it's a theme within Google Cloud across multiple native product services, is the ability to use tags, right? So we can use tags to create policies, and we do this through using the resource manager tags. And what this allows us to do is it allows us to, and denies based on resource has a specific tag. So let's say a resource has a tag, it's a specific type of tag. We can use that variable to actually determine whether we want to allow and deny that traffic, right? So the resource manager tags is used in conjunction with the tags that exist on a virtual machine by either segment or service type, right? Again, more granular, more options. Okay, and we can also use URLs to create policies. So we're really thinking in terms of, like, there's so many different options on us to define that policy, right? So we can use URLs to define the URLs that the users can access. So imagine, like, you're going to a whole bunch of list of URLs, right? And these URLs dictate the destination targets, right? So I mentioned Salesforce as an example, or there's a tremendous amount of other websites out there. But if we were to take the Salesforce example, right, we can say Salesforce it's approved, it's on that list, right, that list of URLs, and we're defining that destination using that URL. Okay, so now let's kind of like shift gears here, right? So in terms of traffic, right, what kind of traffic do we have, right? We can have an automatic traffic. So imagine, again, going back to the Salesforce example, let's say you want to have an API access to Salesforce, right? So now you're going to, there's an internal application within your environment, within Google Cloud, and that's now making an API call to your external Salesforce environment that you have, right? So basically what you can do is you could authenticate to the Secure Web Proxy, right, programmatically, right? So the API access could be using REST or using application default credentials, right? So we talked about traffic, we talked about policies, and I know I mentioned this before, TLS, right? So TLS is very important for securing that connection. And we mentioned one of the advantages that we can use TLS end to end. But let's dive deeper into TLS as it relates to Secure Web Proxy, right? So we're going to look at the following parameters to determine if the TLS connection should be inspected. So really, yeah, we are getting the TLS connections coming in, but should we inspect it? And that is really the big question, right? Do we want to break apart the TLS connection and inspect it and look into it, right? And there are situations where we don't want to do that, right? And then there's situations we do want to do that, right? So what we're basically looking for is we're looking for a TLS underscore inspection underscore enable. And this flag, if this flag is on, then it generates a new service cert. It sends the cert to the certificate authority service, right, to be signed by your subordinate certificate authority pool. This cert is then presented to the client, and a TLS is established, right? The generated cert is cached for a short time to be used on subsequent connections to the same host, right? So this kind of makes it more efficient, right? So in terms of the granular control, we can decide, right, that certain traffic to certain destinations should be inspected and others should not be inspected, right? So that allows us to handle, say, PII data, personal identifiable information data, personal health information, and that kind of stuff, right? So we can granularly determine, like, for example, if you were to go to a specific website, we can say, okay, we don't want to inspect the TLS for that specific destination. For other ones, we will say, yeah, okay. So that's really what we're trying to say here, and looking for that flag on determines whether the traffic should be inspected or not. Okay, so to inspect the TLS traffic, you need to generate a server cert for the host, right? Then the client is attempting to connect to, right? So really what it is, basically, if you think in terms of the analogy here, right? In order for the actual proxy to be able to inspect the traffic or essentially break that TLS connection and establish a new one, it needs to have have the traffic come in, and you do that using a generated cert for the host, right? So the client, so the server is actually using that certificate to communicate, right? So an organization managed private certificate must sign this server certificate, okay? And only clients configured trust this private CA, trust the generated server certs, okay? So, and again, in this kind of description here, right, we are not talking anything specific about Google Cloud, right? This is how, in general, proxies actually work when you have a client that wants to talk to the internet and there's a secure connection, and that's how we basically do a secure encryption. And I do actually have a different video that actually dives deeper into TLS inspection, especially with a proxy in the middle. Okay, and the last statement here is this does include browsers and embedded HTTP clients, right? So as a result, TLS inspection can only be used to inspect and to use to intercept and inspect TLS connections from clients that your org has administrative control over. And that's really important because you can't really inspect traffic, right, when you're using these server sters and the server sters are actually installed on the host, right, anywhere else, because these are part of your organization and you have control over those, and hence you can actually decrypt those. Okay, so not all TLS connections can be intercepted. So remember I said to you at the beginning of this TLS conversation, right? So there's two approaches: situations where you want to inspect the TLS traffic, situations where you don't want to inspect the TLS traffic, and the final bucket of that is situations where you just can't inspect the TLS traffic. Okay, so an example here is certificate pinning. And again, this is nothing new specifically to Google Cloud, right? This is inherent to how, in general, proxies actually work, right? So if you have a proxy and you're doing certificate pinning, it's not going to work, right? So certificate pinning, so machines that are hard-coded to only accept a specific server serve. So remember, these hosts are receiving the actual server certs, right? So it's on the actual host, right? So if you already have one hard coded, it cannot override it, and you're forced to use that, and it's not going to work, and the model's actually going to break, right? So those signed by specific certificate authority services that's outside of Google Cloud, outside of your org's control, is not going to work. So that's essentially certificate pinning, right? Another example is in Windows, Mac OS, and Chrome software updates by specific examples. So for example, think in terms of your Mac, right? So, or your Windows machines, or, your Chrome laptops, right? When they go externally, they're using certificates that are already built as part of the operating system in the trust store, right? And they are actually going to use those certs. So you can't actually now place your own server cert on the actual host, because then when the traffic tries to reach, say, Apple or Microsoft or Google, it's then going to become invalid, right? So the public key and the CA chain of the server creation that the Secure Web Proxy presents to the client do not match with locally stored parameters, and that's what the bottom line there is. Okay, now you can add rules to bypass TLS inspection for specific criteria, and that kind of goes to one of the buckets that I mentioned before. You can selectively choose which connections you don't want to inspect, and that would be a good example here, right? So situations where there is a certificate pinning taking place, or there is the connections to Microsoft, Apple, or Google for those operating system updates that you have. Okay, now you can restrict TLS inspection for specific destination hosts, right? So when we restrict that, how do we restrict that? So we could use fully qualified domain names. We can use sources like secure tags, service accounts, and IP addresses, and we can also use session matcher attribute of a rule. Okay, so if we take it a little bit step further now in terms of, again, still focusing on the realm of TLS, right? So now we're talking about the integration with a certificate authority service, right? So high availability and scalable repository of your private certificate authority service, right? So that is actually, you can integrate the Secure Web Proxy with that. You can use your own root of trust. Okay, you can use an existing root certificate authority to sign for those subordination security authority service held within security authority service. Okay, and you can also generate a new root certificate within the CAS, and a TLS inspection policy. You can, when you're looking at the actual inspection policy for TLS, you can have the same of different ones for each Secure Web Proxy instance, right? So that's important to note there. Okay. Now, in terms of the use cases around TLS and Secure Web Proxies, right? The following are examples where we want to enable TLS inspection. So if you're using an existing root certificate to sign a subordinate CAs held in the certificate authority service of Google, then the subordinate CA held within the CAS is used to sign that server cert generated at runtime. Okay. Another use case is using the existing root CA held externally, again, not in the Google Cloud CAS this time, right? So in that case, to sign the subordinate CAs, right, when the subordinate CAs are signed by a root CA, you can use them to sign the server cert generated at runtime. So you basically, in this instance, you're using a CAS. In the previous example, so using not the Google Cloud CAS, but in the previous instance, you are using the Google Cloud CAS. And then the final use case is use a root cert generated within a CAS. After you create the root certificate, you create a subordinate CA signed by your new root CA. Subordinate CA is used to sign the server cert generated at runtime. And that concludes this module. I have put a link in there if you want to find out more information. So thank you for today's module.